Thank you. Is that all? Thank you. Okay. Okay. Here we go. The first one goes without saying, right? I think most of you got that one right, and the ones that didn't, you probably know now why you got made a mistake there. So it's y and x and y. Uh, remember, if something is increasing, you need to make sure that there's a 1 something, so you need to add this to 1, and this is 5.42. So if you straight up just put 315 in here, you lost a full mark because it needs to at least be a decimal and so forth. So, and then doubling time, yikes, scratch, right? Some of you just need a wake-up call or review. The time stays constant, right? If there's a doubling time of 4 hours, then it's 0, 4, and so forth. It goes up by 4, constant. The doubling happens with the population. So this should have been doubled. You double every time that doubling period goes by. Okay, so you lost a full mark. If it was even a small mistake, boom, -1. Okay, but then I would still honor this. However, I don't know if you notice, a lot of you, I underlined this. I said this should be a flag here, because if you have 0.80, right, this is your initial population. This is your y-intercept. If this isn't 80, you should be like, wait a minute, right? So moving forward, I would actually take off even more because there is a way to know that you made a mistake, right? So I notice I wrote down the other one that a lot of you got. So that way I still give you a mark per step. Okay. And then how long would it take to go from 2,000 to 3,000? Well done, except for 4 decimals, right? If you're going to use these to subtract 4 decimals, sometimes it doesn't affect your final answer. If it doesn't affect, you're just lucky, you don't lose marks, because we are assuming you did use 4 decimals. That's just how we roll, okay? Second page, graphing, you know what? I say that again and again. I can brag about this group. Your graphs are usually pretty good. You're not missing a whole lot. So way to go, guys. And it is time consuming, and therefore it's worth 3 marks, right? So you got to make sure you understand what goes in. So for an exponential, it's decreasing, right? If possible, I'm looking for that y-intercept for sure. And then it comes down, and it should never touch. Way to go, guys. I don't think I found a single one where it touched the x-axis, so that was good. And you can go ahead and put arrowheads on there because it just says include, right, for a time of 20 days. I will probably be specific for up to 20 days or at least 20 days, but I won't say necessarily unless it tells you to stop. Feel free to continue. But sometimes it's hard, like, what do you want, Mr. Dirksen? You want that? Do you want this? What do you want, right? So that's a little bit of a guide, right? And then I have my reference points here. Only one, guys, only one set of keystrokes. You don't need to like give me keystrokes every time. I don't think that's fair. But anyway, so way to go. The units were there, labels were there. It's all good. Okay. So then this was done well, no problems. This was also done pretty well. You're supposed to subtract this from 1, right? Where is that coming from? It's coming from the equation, right? So there is a loss, not of 83%, but of 16.59. Please don't round, especially like if you know for sure it can be stated as a decimal. Don't round. Half-life, well, you take the initial, split it in half. A lot of you just did that and left me with this, 218. You're not quite done yet. That is, you're figuring out, okay, if I go down to half, how long would it take, right? That's what we're asking for, this number right there. And then Y2, how long would it take to go to 200, which is be considered the safe level, right? Then it's 4.3 days. So based on your answer in question E, right? I do indicate that. Go back to E. So it's from time 0 to 4.3 days, and then it's from a level of 200 radiation level to 436.24. Okay, that's where it's at. Okay, so 1 mark for each. You have to have square brackets. You have to have all those things there for it to be considered 100%. Then you had your logs here on question 5. A lot of you mixed up time and volts. There should have been an x-intercept, right? Like x-intercept is part of this graph, right? Because time is 0 there, right? So it can be included. And so I was looking for that. Volts, make sure you have your units as well. If you read further, right, there's volts here. So voltages and volts, I think we all know that. And oh, I was picky. You probably know what I'm talking about, right? I count. And if I do a quick count, I don't like obsess over it, but I do like why is there 4 boxes and all of a sudden you have 5? Like that's not right. So I do check. That's why I give you a grid so you can't tell me, well, Mr. Erickson, that's just a little off, right? Did you measure it, right? Like that's why I do grids, right? It makes it easier for me to check. So that's what I'm looking for. And yes, there should be an arrowhead here, but never touching. And this scale, right? This scale should have been at least to like 12, right? Because you know that a reference point, this point should be on there, right? 1A, like the 11.995 should be on there, right? Because some of you just went like this, right? And your scale here goes to like 5 or 6. It should be higher, right? To include, it should be an appropriate scale. That's what we talk about there. And so this, depending on how you did up there, if you mixed it up, obviously your answers are different. You did the exact opposite. You did the Y2 thing here, second trace 5, and some of you did the second trace 1 here because you mixed up time and voltage. But that's okay. I was like, okay, you made a mistake up here. We're going to be giving you the marks there. The domain of this function, just the domain. Some of you went to give me the range, and if it's wrong, we have to take marks off. So don't try to show me how smart you are. Just stick with domain, okay? And then you would have been fine. But this is when the battery is dead, and the highest voltage here would be 17. If you put 17 down, I actually honored it because the question did say, right? So either one is fine. If you want to range, the range would have been all the way from time 0 all the way to when the battery dies, which is 1492. Okay, if you wanted it, then that's what it would be. Okay, and then the backside, I'm not gonna. It's just find the log, and it's basically what we did today. Some of you did the whole thing, so you got some bonus marks. I felt like you did the work. Might as well give you a little bit. Okay, probability. I don't know if you have your cherry. No, it's not cherry. It's the orange booklets. But if not, take your booklet that you have for this unit. Go to the very back. There's a blank page there. I'm just going to add this to the video of the quiz correction. Okay. So this is going to be an interesting question here. I'm going to put it up. You go to the back of your booklet. You know what? I think if you write this down, you're not going to have enough time. So this is on page 39 of probability. Page 39 in the probability booklet. So maybe just write this down. Just write down what I'm doing here, and then you can go to that question later on and review it. So, oh, is the back of your booklet, Sean? I'm looking at yours. It's not completely blank on yours. Well, there's still a little bit of room, right? If it's not completely blank, find a space there on the back. Okay, so it does say this. Watch. I'm just going to read it. A company screen job applicants for illegal drug use. If you work for CN Rail or CP Rail, they actually do that. They check for drugs in your system. The specific test they use gives a false positive 2% of the time and a false negative 1% of the time. And suppose that 5% of applicants actually do use illegal drugs. We are going to do our tree diagram right off the bat, right? A question like this needs that. So we're going to say there's two options here. Applicants using drugs, not using drugs, right? And we know that using drugs would be 5%, not using drugs, therefore, 95% correct. They don't need to tell us that. And in each scenario, there's a positive and a negative, a positive and a negative. If I run out of time, I'm just going to complete the video later, okay? It says that there's a false positive. When would you be getting a false positive? Using drugs or not using drugs? If you don't use drugs, you would be getting a false positive. It's not going to be this complicated on the test. I want the next part, okay? Just follow along. There's a false positive 2% of the time, which means that you'll be negative 98% of the time. Okay? If you go to the drug users, there's going to be a false negative, right? 1% of the time, and therefore a 99% positive test under those circumstances. So on the test, most likely it's going to be like this. I'm going to get you started. I just need you to do the rest. Okay, so at the very least, I would ask you to find probability of drug user and testing positive, probability of drug user and testing negative, probability of non-user testing positive, probability of a non-user testing negative. You don't need to show me, you just do it on your calculator, and I will give you those numbers. This would be 0.0495. This actually gets you a really small number. Our calculator goes scientific notation on this, but it is this if you convert it. This is 0.019, and this is 0.931. And I checked, it adds up to 1, right? Like if you add up those branches, it should always add up to 100% or 1. What's the probability of testing positive? If the question just asked you that, probability of positive, what would you do? Where do you have a positive? There. And you have a positive right here down this branch, a 0.019. And that gives you 0.0685 or 6.85%. So randomly, if you just randomly test like all of the people, there's a 6.85% chance of actually testing positive among users and non-users. Okay. And this is the kicker here. This would be A. Okay. This will be A. But the B part is asking probability that someone is on drugs, right? Given that they test positive. Like, what if the question asks you, hey, what's the probability that someone is actually a drug user if that person tests positive? So when you read this question, like the given should give it away, right? So you need to come up with a notation. Probability that someone is on drugs or a drug user given that they tested positive. That's what they're asking you for there. Come up with that notation and then you work backwards. So what this is saying, if you have a given, what needs to happen first is that you need to consider drug users and testing positive, because it's these two variables that are in question. So that's how the formula starts. And then you will leave a blank times the notation you just figured out. The probability that somebody actually uses drugs given that the test came back positive. And what needs to go in there? You got to go, like if it's PD, this will be probability of someone testing positive. That's what that would be. So this already happened, right? What's the probability of somebody on drugs given that this happened? Like that's how. So if you just know the alternating P, D, P, right? You just go backwards, and that's another way of figuring out. Drugs and positive, we already know that. It's way up there. Oh, man. I will finish this video, and you just watch it, and that'll be that. You have a bit of a taste of next year if you do grade 12 applied. All right, so we figured out the and comes from here, okay? And the probability of positive we already figured out on the previous question, which is this, 0.0685. And this is what we're trying to find out, so we're just going to call that x. And we're just going to divide both sides by that, cancel out, and that is 0.0495 divided by 0.0685. And that is 0.7226, which is 72.26%. And that would be it. So another challenge, if you'd like, is to figure out the probability of someone actually using drugs given that the test came back negative. And so this would then, you would consider a drug user and testing negative. And this goes over here. So the probability of testing negative is what you want here, which we haven't figured out yet. So this comes from this branch right here, 0.0005. Negative, you just add the two branches that give negative, which is 0.0005 and that. Okay, so you add those two up, and then this is your x. And so let's just clean that up. That would be 0.931. That's the 4th decimal 5, right? X. So we just divide both sides by that. And I need to figure that out. That's actually a very small number, and it's actually 0.003054. So a very small percentage. Sorry, 1 second. Which is 0.05%. And keep in mind, we're figuring out somebody actually using drugs, given that the test came back negative. So there's a small chance of that happening.